Test scores are normally distributed with a mean of 78 and a standard deviation of 10. If 30 students are randomly selected, find the probability that the mean scores will be between 75 and 80. In this example, since it tells us that test scores are normally distributed with a mean of 78, that is our population mean. So our population mean, or mu, is 78, and our population standard deviation is 10. Now, since we want to find the probability that the mean scores are between 75 and 80, that clues us in. We're dealing with a sample. Since we're dealing with a sample, specifically of 30 students, we're going to have to use the central limit theorem. The central limit theorem can be used only if the original population is normally distributed, or if our sample size is greater than 30. Here our sample size is not greater than 30, it's equal to 30, so it's close, but this told us that our original population is normally distributed. Therefore, we can still use the central limit theorem. Let's draw a picture. So we draw our picture here, and in the middle, we're going to put our mean of 78, and we want to find the probability that their scores are between 75 and 80. So we're trying to find the area in between. We need to calculate our z so that we can use our standard normal probability table. Since we're using the central limit theorem, our z value is going to be the mean of our sample minus the mean of our population divided by the standard deviation of the population over the square root of n. This standard deviation divided by the square root of n is known as the standard error of the mean, and it allows to increase our standard deviation to make it more applicable for our samples. So we're going to have to find z for 75 and z for 80. I'm going to take 75 minus 78 divided by 10 over the square root of 30, and 80 minus 78 divided by 10 over the square root of 30. So 75 minus 78 divided by 10 over the square root of 30. We end up with negative 1.64. So one of our z values is negative 1.64. And the other z value is going to be 2 divided by 10 over the square root of 30. We get, let's try that again. 2 divided by 10 over the square root of 30. We get approximately 1.095. We're going to round that to 1.10. And then we're going to have to go to our probability table. We find the probability for 1.10. For 1.10, it is 0.8643. And then for negative 1.64, we are at 0.0505. And now the probability for a score of 80 is everything to the left. So it includes our shaded area and this little unshaded area. The probability for negative 1.64, or for 75, is everything to the left of 75, which includes this unshaded area. So in order to get the area between those two scores, we take the whole area from 80 and subtract away the area that we don't want from 75. Therefore, the probability that our mean will be between 75 and 80 is going to be 0.8643 minus 0.0505. You know you will have subtracted incorrectly if you get a negative number. Probabilities are not going to be negative. So if you ever get a negative answer, you know you have done something wrong. And 0.8643 minus 0.0505 gives us 0.8138.